Okay, so this is part 2 of in class 8. So in part 1 we left off with this guy here. Let me just explain this again. So we're saying the probability that we win at least one game up to 3 is equal to 1 minus probability we lose all 3 games. Again, when you go 1 minus, you're taking lose all 3 games out of consideration. So if you think about it, if you don't lose all 3 games, then what's left? Well, it means you have to win at least one game. So therefore, this is a nice formula to work with here, because we've already found above the probability that we'll lose all 3 games is right here. So let's take that. So I'll put it here. Let's put a new line. So it'll be equal then 1 minus 729 over 1,000. Now the 1 you can write as equals 1 you can write as 1,000 divided by 1,000. Then we're still subtracting 729 over 1,000. That'll be then equal to 1,000 minus 729 all divided by 1,000. And that's going to become then, we introduce it, 271 over 1,000. Okay, so that's the probability that we win at least one game. 1,000 here. Okay, so let's move on to the next question. So we need to find a probability that you win at least one game given that you make it to the winner circle in exactly 2 games. Okay, so we're going to make an assumption here. Okay, put this down a bit. We're going to make an assumption on this, and it's fine to make this assumption. We will assume that the games we make it to the winner circle are games 1 and game 2. If you think about it, it doesn't matter which ones you assume here won't affect the answer. So we're going to assume that just to make the notation easier. And again, just to remind you, we will use this symbol here, like a little straight line, vertical line, symbol, to denote given that. So it'll be short notation for writing given that. Okay, so alright, so let's start working on this. So we're looking for probability then. Well, let's first look at the probability we'll lose all games given that winner circle in game 1 and game 2. And in game 2. So that will be then in turn, we can write this as the probability we lose game 1 given that we made it to the winner circle times the probability that we lose game 2 given that winner circle in game 2 times probability lose game 3 given that do not make it to winner circle. Okay, so that you convince yourself that these things should equal. So this side should equal the other side of the equal sign here. Okay, so let's work out these things. So the probability, going through this then, so let's see, the probability that we lose game one, but we make it to the winner circle, well, that's going to be, given that so we make it to the winner circle, but we lose. So you're in the winner circle, it's just you and somebody else. So the probability that you lose then is 1/2. Okay, so that's the first guy. And then probability you lose game two, given that you made it to the winner circle. So again, since you made it to the winner circle, there's a 50% chance that you'll win or lose. So it's a 50% chance that you'll lose. And the last one, probability that you lose game three, if you do not make it to the winner circle. Well, if you do not make it to the winner circle, then there's a 100% chance you'll lose, right? You can't win. If you don't make it to the winner circle, you can't win the game. So this would be 100%. So the whole thing becomes then 1/4, multiplying those. So it'll be 1/4. Okay, so we're not done yet. So now we can say, like in the previous question, we can say the probability that we win at least one game, given that winner circle in game one and game two is going to equal 1 minus probability that we lose all three games. All three games, given that we win a circle in game one and game two. So the reason for this is similar to the reason for the previous one we just did, because if you go 1 minus, you're taking this guy out of consideration. So the probability that you lose all three games, given that you made it to winner circle in game one and game two, if you take that out of consideration, this is what's left. So therefore it'll be 1 minus that one. So that one we just computed above, so that's the 1/4 guy. So it'd be 1/4 here. And the 1 you can write as 4/4. So it'll be 4/4 minus 1/4. That's going to be 3/4. So the probability that we win at least one game, given that we got to the winner circle in 2 of the games, is 3/4. So pretty much a 75% chance. Okay, so we're done.